We said that very often the keto form predominates over the enol form. But let me show you a molecule in which the enol form is actually predominant. So I'll show you, here's the keto form. And then the equilibrium actually favors the right-hand side. So please write what you think is the enol form of this. It's actually a diketone. And also, it's relevant that the two keto groups are in a 1, 2, 3 relationship to each other. So write the enol form of this 1,3 diketone. It helps to fill in the hydrogens. So there are 2 hydrogens in between the carbonyls, and there are methyl groups on either end. So if you didn't get to the enol, maybe you can try again here. You have to make a decision whether the best enol you can make is going to involve moving one of the hydrogens from here, or maybe it's going to involve moving one of the hydrogens from the methyls. Well, the enol form that we get, and that in fact is present in larger proportion than the keto form, is this one. So what I would like you to think about next, if you haven't already, is why is this such a special case in which the enol form actually predominates? In other words, there must be some factor that is particularly favorable thermodynamically in terms of stability of this enol form. So what might that factor or set of factors be? Well, one thing we might note is that this enol form, here's the carbon alpha to the ketone carbonyl, and here is the carbon beta. And so this is an alpha-beta unsaturated, that is, there's a double bond between the alpha and beta positions. Another way of saying that is that the alkene is conjugated to the carbonyl. And we know that conjugation is an energetically stabilizing phenomenon because of the delocalization of the electrons. So one reason that this enol form is particularly favorable is that the alkene portion is conjugated to the carbonyl. So can you think of another reason why this enol might be particularly favorable? I've drawn this in a kind of suggestive way. There can be a hydrogen bonding interaction between the oxygen of the ketone and the proton of the enol. So this hydrogen bond can also stabilize the enol form in this particular case. So while as a general rule, the keto form will typically predominate over the enol at equilibrium, there are cases where this goes the other way when there's something particularly stabilizing about the enol form.